So when we talk about edge computing, it's one of those terms that's, like Amir said, it's been used widely today. A bit like AI, a bit like orchestration, even like IT itself. It means many different things to many people. I could ask 10 people out there, what do you mean by edge computing? I'll probably get 10 different answers. So I said I'd start with a definition of what we describe or what we define edge computing as. And what we say is edge computing places enterprise applications closer to where the data is created and where action needs to be taken. So that sounds obvious, but that's kind of a definition set in our mindsets of what this actually is about. So think of the network, think of the data center out through the core network, out to the edge of the network, and to the far edge and the user edge as well, if you like. But it's putting that computational compute where it needs to be done, a sensible part of the network. So we take those decisions, we do that compute where it makes sense in the network or in the edge computing platform. So places enterprise applications closer to where the data is created and where actions need to be taken. And what's driving business to the edge? We see a lot of conversations right now around 5G, around lower latency, around AR, VR, and things like that. But really what's driving business to the edge is that with edge computing, a lot of our customers, the technology footprint that they have now is increased. So they've got more to play with that can help them in their businesses to monetize and drive more applications, drive more business applications for them. So we look at latency, need for that real-time insight, action, or decisions. So things like AR will allow us or will require us to have that compute at the edge. It will take too long and it'll be too expensive. Things like video applications, it'll be too expensive to push that always back up to the data center. Bandwidth costs, it's self-explanatory. The data volume and the cost of backhaul will be too expensive. Security and compliance, there's a lot. We have to have secure data at the edge. Not all data can be pushed back up across the network, up to the data center clouds, for example. Our personal data, things like GDPR, etc. Very, very important to consideration as we do edge computing. So we have to have that data at the edge, that personal data, but it also has to be secure. And continuous operation and scaling, managing these disconnected devices, and it's going to be, and we'll see a couple in a minute, some numbers, but there's going to be such a wide variety of devices, and the numbers will be astronomical, right? So how are we going to deal with all of that? It's going to have to be an automated way of operations. It's going to scale, and we don't know what the numbers are going to be. But the key message from this one is that our enterprise customers can now do more because they've got an expanded technology footprint that allows them to develop new applications for their businesses. The edge challenge, so the numbers I spoke to, right? 24 billion IoT devices by 2020. I saw a slide this morning, 100 billion devices by 2025. 2020 statement, that's four devices for every human being on the planet. It's incredible, right? Incredible amount of data. 463 exabytes of data will be created every day by 2025. I don't know what an exabyte of data means. So I looked it up, and the closest I come to understanding how much data that is, if we take every word that was ever spoken by mankind in the history of our universe, all of those words put together will come to 5 exabytes of data. And the analysts are saying 463, like 100 times that, will be the amount of data created every day in 5 years' time. It's incredible. But yet, 1% of that data is actually actioned or understood or taken advantage of today. So there's a lot of work to be done there. So we have all of this data, more and more data to come, all of these devices, but what are we going to do with it, right? We've got to be able to understand that data, we've got to infer that data, so we can make decisions, like we said, close to where they need to be made, that definition of edge computing again. Real client problems require real edge solutions. So we look at some of the different industries that that are affected by edge computing. So industrial equipment, for example. Think of oil rigs. Think of mining companies, things like that. A lot of the time, these guys are disconnected from the network. So we need to be able to make those decisions, those inference of data, those inference of those decisions close to that where that data is being collected. So in a mining company, if they lose connectivity to the outside world, we still need to be able to make those decisions. Manufacturing machines, for every hour of downtime in an industrial manufacturing plant, it's $250,000 is one of the figures I've got from a company that does wind farms. So these things are really expensive, pieces of equipment, lots of instrumentation, collecting lots and lots of data, and but every hour of downtime is $250,000. That's quite significant, right? If we can help with that. Connected vehicles, we're all fully aware of it. Lots of different use cases around that, and of course, telecommunications, telco industry that a lot of us are near and dear to. Decrease those operational costs, enable those IoT devices, enable those 5G low latency applications, etc. 10% of that data is created and processed outside, a traditional data center today. In 5 years' time, in 6 years' time, we're saying that that's going to be 75%. So that data that's collected and aggregated at the edge will be processed at the edge as well. How we do that processing, and we'll get into this a little bit with AI and things, some of the models and some of the analytics that we will use to process that data, they may be developed in the cloud or may be developed in the core data center, and maybe once a day or whatever that use case is, they'll be deployed at the edge. But again, like the mining, if that's cut off from the network, or a cruise ship, for example, so you've got a cruise ship with hundreds of people on it, we want those analytics on the cruise ship doing their magic, but you may have no connectivity to the outside world. But those analytics can still collect all of that data that's being generated on the ship and make decisions with that. Again, just another example, the augmented reality example. I think a lot of people are aware of it. I listened to the CEO of Verizon about maybe 18 months ago at an IBM conference speak on stage, and he made a statement that I couldn't really understand at the time was, with 5G, our mobile phones' batteries will last a month. Right, and we're all very aware of, I see people here, I tripped over the wire a second ago, plugging in their mobile phones to get more, more juice, right? But as we move the battery, offload the computation to an aggregated edge thing, away from the actual device itself, that will save on battery power like that. Things like augmented reality, virtual reality, they require that low latency. Why? Because if there's a disconnect between what the human can visualize and the movement in the goggles or whatever, we will get physically sick. I've experienced it myself. It's not a nice feeling. That nausea of, if you go to any of those gaming shops where you kind of sit into those diving suits or you sit into those driving cars experiences, it's quite sickening if that latency isn't there. But having those applications at the edge close to the end user, who can then have a lightweight goggles on or a lightweight headset or their phone, we can offload that computational power to the edge, off the actual device itself to the edge. That's going to save a lot of power for the battery. 10 millisecond, sub 10 millisecond latency to 5G base stations. That's going to be quite important. So things like 5G and edge computing, they're complementary to each other at the edge of the network to facilitate those new applications, etc. But how do we do that then? So edge computing, we talked a lot at this conference. I think it's my fourth SDN World Conference I'm at. Over the last number of years, we heard people this morning talking about NFV, and it's been around for 7 years. And where's the journey going to end up, or what are we doing with the journey, right? But edge computing provides an extension of the telco or the network cloud to enable compute power at the source of the data. Like I said, that definition of edge computing. And when we look at these kind of three circles here, if you look at the central hybrid clouds over here on this side, over here, the public cloud can be your Amazon, it can be your Azure, it can be where application development is done. But these private clouds here and the local and regional edge clouds, that can be the CSP or the telco's network itself. There was a conversation this morning about collaboration, right? There will be intense collaboration between the telcos, between the application developers, between the public cloud guys in this new world, right? And as we move across here, we have, NFE is happening in the network today. We are disaggregating the core of the network. Things like the packet core is being disaggregated from its hardware. It's being disaggregated from its infrastructure layer, and people are bringing it back up together again for that best of breed kind of disaggregated stack to bring the benefits of cloud computing, frankly. And it's moving out to the RAN now, the virtual RAN, and we see it, and we will get towards cloud native eventually as well. Comment this morning was made, there is none. Well, we're seeing, lots of development efforts behind cloud native network functions right now, in particular around the mobile core and mobile edge there. And as we offload then to the campus network or to the enterprise network, we will see lots of computational appliances there as well. So there will be networking and enterprise workloads working together, both in the edge of the telco network, but also at the edge of the, or in the actual edge itself in an enterprise campus network, for example, in a manufacturing plant. They might even have a private 5G or something base station on the roof, as an example. But the benefits of an edge computing platform, and if we get this right across all of the network, it's that disaggregated stack, lightweight distributed computing platform that supports both the data and the AI workloads. That AI is important to understand what we're going to do with that data. Remember that 1% of that data is actioned today. That low latency real-time actions to be taken on-prem or on the device. Better privacy, regulatory concerns. We heard a gentleman from Ofcom this morning talking about those regulatory concerns. Very important. We have to acknowledge it. They are trying to protect us as consumers. Transport costs, storage costs, processing costs, it's self-explanatory, right? If we want to take, video cameras all around The Hague, and if we want to send them up to Amsterdam for processing, that's going to cost a lot of money. If we can do that processing and inference local to the device, local to that video camera at the front of the building, that makes more economic sense, right? But we need those models, we need those data models there to do that inference as well. And back to the example, it enables workloads to operate autonomously when disconnected from the network. Those cruise liners or those mining companies, those manufacturing plants that have disconnected from the core network or from the mobile network, they still need to operate because there's huge costs when they don't. Those wind farms, the $250,000 an hour cost if this thing goes wrong, right? So hugely important. So we see the network cloud and the edge clouds as complementary to each other, and edge computing extends the network cloud. So all the work we're doing with network function virtualization, with SDN, etc., that cloudification of the network can be extended now to help with these edge use cases. On that point, network virtualization, cloudification, and automation are key. Words that may be overused. So, network virtualization, what happened? We replaced those physical boxes, those physical appliances, decomposed them, and we have these, the software and hardware disaggregated now. We call them VNFs, right? Things like that. Network cloudification is all about taking advantages of what cloud computing can give us, right? So optimizing the capabilities of the cloud itself, a cloud-based network. We haven't seen, I come from in IBM, 5 years ago, or 7 or 8 years ago, we looked at moving software to the cloud and offering that software as a service to our customers. A lot of our footprint was existing on-premise application software, middleware software that we ship to our customers. You cannot put AAS after a piece of software and call it as a service. In the same way, you can't put V in front of a network function and call it a virtualized network function. It doesn't work like that. You've got to design it for the cloud, build it for the cloud. And then, of course, network automation, a new level of automation based on AI, machine learning, all of the techniques that are out there today is required, to help us take action, to help that edge computing infer the data, take the right action, the right next step, to make sure everything works accordingly. And when we describe that, we say creating a living network with a mind of itself that enables itself to sense what's going on, when it's going to change, and what to do with that change. What's important from that then is that we place these workloads, we decide where the computation needs to take place in the sensible part of the network. It doesn't make sense to push every application out to the edge of the network. There's monetary reasons. I heard once that it was 6.5 times more expensive to deploy something out there. Consumer applications may make sense out there. The mining example may make sense out there, but not everything is suitable for the edge. So we've got to make sure we make a sensible decision on where we put our network and our enterprise workloads along that end-to-end. If you remember that 3 bubble slide a while ago, that end-to-end of the network. A little bit more on that, designing networks for the cloud with AI and automation. We have to have the end-to-end focus. We have to consider the enterprise and the network underpinning that enterprise application from the get-go. We need that machine-enabled automation. We need the computer to take over from us. We cannot have fingers and keyboards. And what I really mean by that is, we can't just script automation, or we can't just take a process from yesterday and say, let's automate that process. All we're doing there is reinventing, saving a little bit of time, but it's still costing us a lot of money to put those hands on keyboards to build those scripts, right? Automated testing, we've got to build, in a particular, learning from the IT world, right? I said I came from that world, and we've applied those principles here. Things like behavior-driven testing, things like automated testing through your build of your day zero, right? So when you're designing your network services or designing your applications, test, 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 test. But as you go through each staging life cycle from your test environment to your staging or pre-production environment into your actual production rollout itself, keep those tests working all the time, those behavioral-driven tests. As we get into production, the network is a finite set of things, if you like. Things change all the time, so those tests become really important. And let's be open. We have to be open about this. A very interesting conversation earlier around the APIs and the whole, every SDO out there has a different set of APIs. I was in a conversation with a customer yesterday in the UK with a telco, and one part of the business, they wanted us to adhere to the broadband MEF APIs. The core guys wanted the Etsy Mano APIs. Another part of it wanted own app APIs. So there's a lot of APIs, but there has to be openness out there. We have a lot of work to do to bring this stuff together in a more consumable fashion, and that's collaboration across vendors, across ISVs like IBM, across system integrators like IBM, but also with the clients themselves. Complex dependencies, this is not meant to scare anybody, but it's complex dependencies across multiple cloud technology layers. These enterprise edge cloud and networking workloads must cooperate across all of these independent layers. If you look at that top left here and just think that as one of those video cameras at the edge of the network, for that to happen, there's the mobile core and the packet core router, and all these things have to be stood up. There's enterprise connectivity between those packet cores, between the different regional clouds, for example. And these things might be sitting on OpenStack, on VMs, or typically on Kubernetes pods as well. But each of these layers services the layer above. And when this thing gets broken or has to move, that the AI kicks in and says, you need to move that workload from this pod to this pod, and it moves over here. That has an impact on all of everything we see below the line there. So we need to manage all of that change automatically. We can't workflow our way out of that, right? Each layer needs to be designed and managed with that in mind. And a lot of the time, we got to, when we're doing the day zero build, when we're standing up these clouds, if you like, we've got to keep those day one and day two operational use cases in mind as well, because things will break, things will need to be healed, scaled, moved, etc. The life cycle actions of any piece of software. So we've got to keep that in mind as we design these things in day zero. I spoke a little bit about DevOps and cloud. We do need to apply a new type of operating model for this world of cloud-based networking. We've got to understand and build that automation, build that inference into the design. We've got to understand that when things go wrong, we can get the machine to take over. How can we have the automation to kick in itself and make decisions on its own without having to get a human involved all the time? And that's kind of flipping the world of OSS on its head a little bit. But we can learn from the IT world again concepts like SRE, site reliability engineering. We've got people in my organization whose job is to make sure that the applications running in the public cloud are always running. But they spend 50% of their time, optimizing the network, trying to get ahead of any problems. Things like predictive analytics, things like understanding something's trending the wrong direction. Us as consumers, all the lights may be green, but we can see from all the data, back to that 1% of data, let's take advantage of the data to get ahead of the problem, right? And then we can spend the other 50% of the time. There will always be problems, something will fail. But this network secure DevOps type of operating model is required for this world. We in IBM have a network cloud that has an operational intent-driven approach. We have a standard lifecycle model. Every network function, we make it look the same. We have this intent-driven orchestration. And really what this is about, it's modeling dependencies and relationships, not trying to model every possible workflow. So we tell it, this is what I need to look like, and it takes care of it. So if something happens, the intent engine takes over it takes over. And the analogy we use is like a sat-nav. I want to go from The Hague to Amsterdam. I don't know the route. As I'm on my particular route, there might be a crash. I get rerouted automatically. In the same way, that's how we apply automation to the network and help us for that machine-enabled automation to get ahead of any problems. And of course, that cloud-based DevOps toolchain. And then, like we said, the network cloud is enhanced by this IBM, or enhanced by edge computing. So we in IBM have recently launched our IBM Edge Computing Fabric. It's an extension of the network cloud. 4 key tenets that we have. It's intelligent, it's open, it's scalable, and it's protected. And really the goal is that you build it once, you can deploy it wherever you need to, and you can operate and manage it from anywhere. That's a key important tenet of what we do with extending that network cloud towards the world of edge computing. And finally, from an IBM perspective, and with Red Hat as well, of course, we've got the booths out there, so we're demoing some of this stuff. We do have a breakfast meeting in the morning, which everybody's welcome to attend. It's at 8:30 in Asia Room, I believe. And with that, I'm going to wrap up and I don't know if I have time for questions or if anyone's got a question. Okay, any questions out there? Okay. With that, thank you for your time.